From this video, we are capable enough to learn about the heart of natural language processing. I hope you have watched my all previous videos. If not, first watch my all previous videos related to natural language processing. It will be easy for you to understand about further topics and projects. Now, let's move to recurrent neural network. Before this, what is neural network? A neural network is a circuit of neurons. Neural network are two types. First, biological neural network, where the dendrites receive the information from another neuron, and the cell body or soma process the information coming from dendrites. Neurons send the information through a cable called axon, and finally pass to another neuron dendrites through synapses. And second, we have artificial neural network. Generally, we consider only artificial neural network, that is the network which try to mimic biological neural network. Related to this, we have another convolutional neural network, which is different topic. But many people get confused with recurrent neural network and convolutional neural network. So give me about 2 minutes to explain convolutional neural network. If you get confused anywhere in this convolutional neural network, don't worry. Just try to get how much you can. So, let's begin. Convolutional neural network, CNN, is a class of deep neural network, most commonly applied to analyze visual imagery. We call it convolution because in this, we multiply each pixel values by weights and summing them. In CNN, we have 4 steps: convolution layer, normalization, pooling and fully connected. Suppose we have 8 by 8 dimension image. We can't pass images directly, we need to convert images into matrix form. Let me choose 3 by 3 dimension filter which contain random weights from W1 to W9. We need to map this filter to all around 8 by 8 dimension images, and update the weight in the middle position by computing dot product between them, and finding their average value. We can't compute value for border side as we can't put our filter there. So we have to insert 0 in the border area. We need to repeat this step until we get new matrix. Finally, after this step our matrix get reduced to 6 by 6 dimension. We can apply this step to any RGB image which has 3 channels because it has 3 color, right? And we can take as many filters as we want. Finally, we get new matrix for red, green, and blue color images. Next step is to normalize them. We can use ReLU activation layer which convert negative value to 0 and do nothing to positive value. You can compare the matrix before and after the normalization. Next, we have pooling layer which does nothing more than reducing the dimension of the matrix. We can have max, min, and average pooling. If we take max pooling, then just pick the maximum value from each pooling window. That's it, you can compare the output by yourself. Finally, we have fully connected layer, where we reshape our matrix into one dimension which will be treated as input to the neural network. We can repeat first 3 steps as many times as we want. So we have loop over there. This is how CNN works. If you get it, great, and if not, that's okay. You can continue further. Back to the artificial neural network, it is used for classification and regression problem, whereas convolutional neural network is used for computer vision and image processing related problem. But what is recurrent neural network? In short, we can say RNN, which is type of artificial neural network that uses sequential data or time series data, for example, to predict next word from the previous word. For this, it has the capability to memorize parts of an inputs and use them to make accurate prediction. In RNN, output from previous step are fed as input to the current step. These networks are the heart of speech recognition, machine translation, image captioning and other real-world applications. Before moving forward, you must have to know how simple neural network works. In step 1. First we have our input. Suppose our input is the dataset of image classifier. We will use that dataset and apply some complex computation using randomly initialized weights and biases. Again I repeat, our weights and biases will be some random value at the beginning. Then we predict images. Obviously at this time, we don't get accurate prediction. So in step 2, we calculate an error which is equal to the difference of expected value and predicted value. Then we apply backpropagation where we adjust weights and biases. Then repeat step 1 and step 2 again and again until we get satisfied with our final result. We then predict output with new unseen input. That's how neural network works, right? We have to keep this principle in our mind because this is the general working way of any neural network. Now, I have one question. Is recurrent neural network different from the simple neural network? Let me show you the composition of RNN. This is the diagram of basic neural network. To convert this into RNN, we have to apply several modifications. First modification is to squash each layer of network together. That is, merge them. Second modification is to connect network by a single line. Third modification is to rotate network by 90 degrees. Fourth modification is to generate loop around the hidden network. This is the final recurrent neural network. We can also unroll this architecture. You can see the difference in architecture of simple neural network and recurrent neural network. In RNN, each output from the previous layer are fed as input to the next layer, as I have already mentioned. Now, how RNN works? This is the same architecture we have seen before. We have input, hidden layer, and output in each step. In RNN, suppose if we want to predict the next word from previous one. First of all, each word is transformed into the machine-readable vectors, we all know. Then the RNN processes the sequence of vectors one by one. But it includes some difficulties. If the next word to be predict is dependent on another word that are far away, then this may fail to predict accurately. For example, if we have sentence, color of apple is, RNN may return true answer, that is red. But if we have another sentence, I grew up in Nepal, I speak fluent, the word to be predict is dependent on the previous sentence. At this time, RNN may fail. This type of problem is called vanishing gradient problem. That is, network face difficulty in memorizing words from far away in the sequence. If a gradient value becomes extremely small, it doesn't contribute too much learning. Therefore, it makes predictions based on only the most recent ones. To deal with this problem, we have LSTM, long short-term memory, and GRU, gated recurrent unit, which we will discuss in the next topic. I hope this RNN video is clear to you. If you have any question, ask me in the comment section. Like this video, subscribe my channel IG Tech Team. I will meet you soon. Stay safe and keep learning.